Hello class, it's Miss Rania. We are going to be working today. We will be starting chapter 5, Electrons and Atoms, lesson 2, so 5.2, Electron Arrangements in Atoms. We will find it in our textbook, pages 124 to 128. Our objectives for this recorded lesson are to identify electron configurations. We need to know what are electron configurations. What do they mean? Why do we need them? And we will be concluding the right way to writing electron configurations, which is the core of this recorded lesson. You will have to watch this recorded lesson before live session 2 because this is video number 2. So we've learned in the previous lessons that an atom is made up of even smaller particles, right? Which is pretty amazing because atoms are already insanely small. So the particles that are present are first of all electrons, which are negatively charged and located in the electron cloud. And our second subatomic particle are protons, which are positively charged and located inside the nucleus of an atom. Just like this is a typo, okay? We have neutrons. Neutrons have no charge. They are neutral, no charge. They're also located in the nucleus of an atom. So Bohr told us that atoms have a central nucleus with protons and neutrons inside, with electrons that roam around in orbitals around the nucleus, just like how planets orbit around the sun. So let's take a look at the motion of these circular shells around the nucleus. Okay, let's have a look here. We have the nucleus in the center. Let's write it down. We have the nucleus in the center of the atom, and the electrons are orbiting around the nucleus. Okay, so these circles that electrons orbit in are referred to as energy levels. I hope this point is clear. Electrons roam around in levels, different circles, and these are referred to as electron energy levels. So the more I want to go farther from the nucleus, the more energy it takes, okay? What are these energy levels called? Principal quantum number. These principal quantum numbers, or what we simply call energy levels, are numbered. For example, we have here the first energy level, n equals 1, second energy level, n equals 2, third energy level, n equals 3, and fourth energy level, n equals 4. Energy levels can hold a specific number of electrons. So, in each energy level, they are technically separated into sublevels. Okay? These sublevels are mentioned here. So think of it as the nucleus, sublevel 1, sublevel 2, sublevel 3, and sublevel 4. There are 4 main sublevels, and this is the list. So we have here 1, 2, 3, 4. Sublevel number 1 is noted by the letter S. Sublevel number 2, letter P. Sublevel number 4, letter D. And sublevel number 4 is F. We have to keep these values in mind. What are these values? These values are the number of electrons. So in sublevel S, the first sublevel, it can hold a maximum of 2 electrons. So 1 to 2 only. Okay? Sublevel number 2, which is P, can hold up to 6 electrons. So 1 to 6 electrons only. Same goes for the sublevel D. It can hold 1 to 10 electrons only. And sublevel F can hold 14 electrons only. Okay, طيب, okay, but you told us the numbers. What's the point? How will we use them? Why do we need them? Well, we'll be using them in electron configuration. But what is electron configuration? Electron configuration is an electron's arrangement in the orbital around the nucleus of an atom. So in simple words, we can say that electron configurations are the specific address of an electron where in sublevels. Okay? So it's technically an address to tell us where this electron exactly is. Okay, so we simply agreed that an electron configuration is the address of an electron in the suborbitals of an atom. Let's take a look at the periodic table and identify the locations of these sublevels, or what we call blocks. First of all, we have the S block, which is mainly in groups 1 and 2 of the periodic table. S blocks can carry a maximum of 2 electrons. Keep in mind that helium is also a part of the S block. And then we have the P block. The P block is groups 3 to 8 almost, and it can carry a maximum of 6 electrons. Then we have the sublevel D, which are the transition metals, and it can carry a maximum number of 10 electrons. Finally, the inner transition metals, which are located as this in inner transition metals, which are the F sublevel, F block, which can carry a maximum of 14 electrons. Let's take a look at how we can write the sublevels that will tell us how to write electron configurations. 2 is the energy level. What do I mean by energy level? Let's take a look at the periodic table. The groups, the rows of the periodic table, the periods are the energy levels. Okay, let's keep this information in mind. And then we have the energy sublevel, S, P, D, and F. And finally, the number of electrons at the top. Keep in mind, the number of electrons should have the total number of electrons present in the periodic table. The number of electrons for the S block can be 1 to 2, P block 1 to 6, D block 1 to 10, and F block 1 to 14. Let's practice, but keep in mind the number of electrons at the top should equal the total number of electrons in the periodic table. Let's see. Write the electron configuration for the following elements: lithium, potassium, boron, sulfur, and nitrogen. Let's start with lithium. Of course, the first thing we should do is refer to our periodic table. Lithium. First, locate lithium. Where is it? Lithium is here in the S block. How should we name, or how should we number it? How can we find the electron configuration? Go from the first until you get to lithium, okay? Go easily in order. For example, let's start here with the hydrogen. So hydrogen is 1s1, and then helium 1s2. And then we got to the lithium. So now we have 1s2, and then lithium is 2s. Lithium is 2s1. How? First, second, which is why we got 2 at the top, and then the second row, which is why we have 2 here, S because it's located in the S block, and 1 because it's the first one. So the electron configuration for lithium is 1s squared 2s1. We have to check the number of electrons. 2 plus 1 equals 3. Number of electrons in the periodic table is 3. Our second example is potassium. K. Keep in mind the atomic number is 19. I'm also going to show you how we solve this one, and then you are going to practice on your own. First of all, like I said, we should locate this electron. Where is potassium located? Potassium is here. It's in the 4th row and still in the S block. Let's start. 1s, 1s1, 2s. Oh, we made a mistake. 1s1 for hydrogen, 1s2 for helium, 2s1, 2s2. And now we have the P. So we're not in the S block anymore. So here, we're still in the 2nd row. So 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. We are done with p6. So far, we have 1s squared here, and then we have here 2s squared, and we have here 2p6. Let's go to the 3rd row. Of course, we have to write 3, 3s1, 3s2. So we have 3s squared. Now we're back to p. So 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. So we have 3p6. And then finally, 4s1. So let's write it out clearly and neatly. 1s1, 1s2, 2s2, 2p6, 3s squared, 3p6, 4s1. Let's check our answer. The atomic number is 19. So we have 6 and 6, 12. 12 plus 2, 14. 14 plus 1, 15. 15 plus 2, 17. 17 plus 2, 19. So our answer is correct. Do we get it? Now we have boron. I'm going to give you a timer of 1 minute and 30 seconds. And you are going to be doing the electron configuration for boron. Use the periodic table. Keep your notebook handy. As you solve, I'll be erasing so we can prepare for our next examples. Pay attention to the timer. First of all, locate the element and note down the atomic number or the number of electrons in this element. And then simply go in order, straight lines till you get to boron. Remember, this is the S block and this is the D block. P block. We have around 30 more seconds. Are we getting it? Are we on the right track? I really hope so. Time is up. Let's see how we can solve it. Please check your answer with me because I know we can do it perfectly by now. Let's start numbering from the top. First, locate your element and then start numbering. So we have 1s1, 1s2. So our first part is 1s2. Move on to the second row. 2s1, 2s2. So what we have, our S is done. So again, 2s2. 2. Then 2p1, because this is our first element in our p block. So 2p1. Let's check our answer. The atomic number for boron is 5. So 2 plus 2, 4, plus 1, 5. We are on the right track. Okay? Let's check another example. Sulfur. I'm also going to give you a timer so you can solve sulfur on your own. Locate it, put the S and P blocks, and then start working. So our sulfur is located here. Pay attention to the timer. Time is ticking, so be careful. The electron configuration for sulfur is going to be pretty big. Let's see. I hope you're doing it right and we're on the right track. Ten more seconds. And time is up. Let's check our answer together. I really hope we're doing it right. Sulfur, we located it. It's in the P block in the third row. Let's see, third period. So we have 1s1, 1s2. So this is our first. 1s2. We are done the first row. Let's go to the second row. 2s1, 2s2. So we have 2s2 because we finished the S block. Going on to the P block. 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Let's go to the third. 3s1, 3s2. And then 3p1, 3p2, 3p3, 3p4. Let's check our answer. Atomic number or number of electrons for sulfur is 16. So 6 and 4, 10 plus 2, 12 plus 4, 16. So our answer is correct. I really hope you are getting it right, okay? So we're done with sulfur. Let's get to our last example, nitrogen. I'm going to give you a timer. Please start working. Nitrogen is a pretty small and easy one, so we better do it right. Forty more seconds. Are we on the right track? Are we getting the electron configuration for nitrogen? Check your answer by checking the number of electrons, okay? Time is up. Let's check our answer. Nitrogen, 7. Let's start. 1s1, 1s2. Why do you think we stop at 2? Because S can hold a maximum of 2 electrons, remember? So we have 1s2. Second one, 2s1, 2s2. So we have 2s2. And then we got the P block now. So 2p1, 2p2, 2p3. So this is the electron configuration for nitrogen. 2p3, 1s2, 2s2, 2p3. Let's check our answer. Atomic number is 7. 3 plus 2, 5, plus 2, 7. So we are on the right track. Now, my dear students, we are completely ready for our second live session. Please watch this recorded lesson before your second live session, and I hope we are fluent enough.